This example is asking us to, again, differentiate. Differentiate just means find the derivative of the given equation, so this f of x here, and then they always put in that little extra language with respect to x. That's just telling us what our variable is, and it's x like we would expect. So we end up with f of x equals, and if you write this out, you know how you're more likely to have seen this written is without any parentheses around the top and the bottom. But if you can put those in for yourself or visualize it with them, it will definitely make this problem a lot easier to see. When I go to look right now, the first thing I always do before I rush in to take the derivative is I look for any algebraic rewrites that might be possible. This one doesn't have any of that going on. The next thing that I notice immediately is that I've got a lot more happening here than just a bunch of stuff being added and subtracted. I've got things being divided right now, so this equation is more than just going to be a straight up power rule, which means we're looking at one of our alternate rules: product rule, quotient rule, or chain rule. Whenever I go to look at a problem, I always tell people sort of squint your eyes and see what the shape of it looks like. And when I look at this problem, this looks like I've got something on top divided by something on bottom. Really, I'm looking at two chunks being divided right here. And whenever I have two chunks being divided, that tells me that my primary rule that I need to run through is the quotient rule. So all of the rules, I have what I call recipes for them. My recipes might vary from what your teacher specifically says, but they all work the same. You just need to find the recipe that sticks in your brain so that you can dump it out as soon as you need it. So what I do is I come through and I label the top piece here the high piece, and I label the bottom piece the low piece. And then my recipe for the quotient rule goes low, and then d high, minus high, and then d low. And all of that is over the low squared. So low d high minus high d low, all over low squared. And when I talk about the d high and I talk about the d low, that's just my way of saying the derivative of that chunk. So to apply that to our specific situation, what I always do is I just kind of break these problems out into bite-sized little chunks. I've got my high piece up top here, so I know the high piece is going to be 3x cubed minus 6x plus 9. And then we've got the low piece, which is going to be the 5x to the fourth plus 3x squared. So to follow my quotient rule, to follow my recipe over there, I need to go find two additional bits of information. I need to go find the d high, so the derivative of the high piece, and I need to go find the d low, the derivative of the low piece. So to do that, what I now do is I look at them as two separate little math problems. So looking at just the high piece, I notice that everything is now just being added and subtracted. So to find the derivative of that, I just need to follow the standard power rule. Remember, really everything flows back through the power rule. So our power rule saying, that I use at least, goes bring the power down and then subtract 1 from the power. So applying that here, I bring the power down. I get 3 times 3 gets me 9x. Subtract 1 from the power gets me x squared. Moving on to the next piece, there's that unwritten 1 on that x, so I bring that 1 down. 1 times negative 6 gets us negative 6, and then we end up with x to the 0, and as you probably know, anything to the 0 power is always 1, so we don't need 6 times 1. And then the derivative of 9, the derivative of a constant, is 0. It goes away. Now we come over and look at just the low piece and say, all right, if that's my math problem, how do I find the derivative of that? Well, again, that's just a bunch of stuff being added and subtracted, so we're again going to apply that power rule. So we'll bring our power down. 4 times 5 gets us 20x. Subtracting 1 from the power gets us x to the third. Then we bring our 2 down. 2 times 3 gets us plus 6x, and then subtracting 1 from the power gets us x to the first right there. So at this point in the process, I have all of what I call my ingredients. I have everything I need to follow my quotient rule recipe. So to find our derivative, we just put all the pieces together following the recipe, and we're done. So the recipe says, first go grab the low piece. So I go grab the low piece. 5x to the fourth plus 3x squared. Then we need to multiply that by the d high, the derivative of the top. So that's going to give me 9x squared minus 6. Then we get a minus from our recipe, and then it says go grab the high piece. So we go grab the high piece. 3x cubed minus 6x plus 9. And then multiply that by the d low, so the derivative of our low, which is 20x cubed plus 6x. And then all of that is over the low squared. So again, grab your low piece, put it in a set of parentheses, whatever it is, and square it. And that's it. That is your final answer. Get up, walk away. That's your derivative right there. So don't worry about simplifying it. Really, my rule of thumb is the only time I look to simplify my derivative is if I have to go on and do more work with it, like possibly finding a second derivative or, who knows what, maybe finding a critical value. You'll see other situations later on, but when someone's straight up just asking you to find the derivative, you follow your recipe, put all the ingredients where they belong, walk away. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.